Phosphorus was discovered in 1669. Dmitry Mendeleev is considered the father of the periodic table, and elements are arranged into groups and periods. This is Learner's Aid, where scholars are made. Hundreds of years ago, there was this German alchemist known as Henning Brand. He had this strange idea. He believed that, or he thought that, if he burned urine into a very concentrated paste, he will be able to make a substance that will be able to turn any ordinary metal into gold. Can you imagine? So he really believed that, to the extent that he actually went ahead to try that. So he burned and tried to burn up his rotten urine that he has collected to try to make that concentrated paste that is able to convert any ordinary metal into gold. But surprisingly, he wasn't able to do that. He ended up making a very glowing paste that glowed in the dark. And later on, it was discovered that the thing he ended up discovering was actually phosphorus and not that special paste he was trying to make. And interestingly, phosphorus ended up being an excellent first element that has been discovered by this man. And mind you, phosphorus ended up being the first element that is being discovered. So scientists of the time wondered, okay, if elements like phosphorus was lying down in plain sight, waiting to be discovered by accident, what about other elements? Is there a possibility that there are dozens of elements waiting to be discovered? And they were really right. So as a result of this one experiment by this German alchemist, other scientists were encouraged to try to see if they can also discover elements out there. And they were really able to discover elements that actually existed. But sadly, these elements that scientists discovered were just random. They discovered a lot of elements, hundreds of elements, but the elements had no order until this man called Dmitry Mendeleev, who was considered the father of the periodic table, came along to arrange elements in increasing atomic numbers to put some order in the confusion that already existed. And mind you, Mendeleev is not the first one to come up with some kind of table to make sense of the elements that were existing at the time. But it was the one who was able to arrange it in such a way of increasing atomic numbers to actually leave even spaces for elements that were not discovered, believing so well that those empty spaces will be elements that will be discovered that will fit the properties that he think those elements should have. So over the years, periodic table has become so instrumental to the study of chemistry. So in this lesson, we'll be considering how the periodic table is and try to understand how the elements are organized on the periodic table. So let's get right in. So what is the periodic table? What is periodic table? The periodic table is a systematic arrangement of all known elements based on their atomic number, electron configuration, and reoccurring chemical properties. That is quite long but easy to remember. This definition has parts. First of all, it is a systematic arrangement of all known elements based on their atomic numbers. What does that mean? Don't worry yourself too much. When we get to Form 2 and Form 3, we'll get to understand into detail what an atomic number actually is. And it's also based on their electron configuration. This is also something we'll be explaining into detail when we get to Form 2. And then one interesting thing is that this arrangement of elements into the periodic table tend to show reoccurring chemical properties. But let's spend some time to understand one part of this definition. arrangement of all known elements based on their atomic numbers. Look at this periodic table. All the elements here have been arranged based on their atomic numbers. What does that mean? Each box you find in this periodic table is an element. And for each element, for example, we'll be considering beryllium. That is the fourth element on the periodic table. Each of the elements has a number at the top right corner. And for this one, the number is known as the atomic number. So all elements found on the periodic table have what we call the atomic number. And then we also have the chemical symbol and then the element name. So all elements on the periodic table have an element name. For this particular one, it is called beryllium. And also a chemical symbol. For this, it is BE, capital B, which is simply the first two alphabets of the name beryllium. And the first alphabet is capital followed by the next alphabet, which is small letter. And then there is an atomic number. And that runs for all the elements that we have. If we visit the definition that we had earlier, that is periodic table being a systematic arrangement of all known elements based on their atomic number. Based on the atomic number. So look at this. So you can see that beryllium is having atomic number of 4. So when we start from the extreme left of the periodic table, the first element that we have is H, that is hydrogen. If we check the top right corner, there's a number written there, that is 1. That means hydrogen has atomic number 1. Now move to the extreme right of the periodic table. We have He, that is helium. There is a number at the top right corner, that is number 2, meaning helium has atomic number 2. So hydrogen is 1, helium is 2. Then moving back to the left, we have Li, that is lithium. Lithium has number 3 at the top right corner, followed by beryllium, and then boron to the right. So what that means is the arrangement of the elements on this table follows the order of their atomic numbers. So we have hydrogen 1, helium 2, lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, neon 10. So that is basically what the definition is trying to tell us. That is the arrangement of the element based on their atomic numbers. And then I've told you earlier that in Form 2 and Form 3, we'll get to understand what we mean by the arrangement of the element based on their electron configuration and reoccurring chemical properties. But for now, all I want you to know is this definition. Now let's move to how the table is organized, the periodic table, how the table is organized. For starters of your level, the only thing I want you to keep in mind is the table is organized into 2 sections, periods and groups. So let's start with the first one, periods. The periods are actually the horizontal rows of the table. So for every periodic table, there are actually 7 periods present in the periodic table. What does that mean? Take a look at this table out here. The periodic table has horizontal rows, and we have 7 of them that make up the periodic table. And the first row is this shown in red there, red rectangle around it. So for row number 1 of the periodic table, we have only 2 elements out there. That is hydrogen and helium. The second row is this: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So the third row follows starting with sodium and ending with argon. Then the third, that's the fourth, the fifth, the sixth, the seventh. So in total, we have 7 rows. So basically what that means is that the rows are the horizontals of the periodic table. So every periodic table has this horizontal called the periods. So the period are basically what? The horizontal rows of the table. So we have 7 of them. And this period, each period shows elements whose atoms have the same number of electron shells. This also, do not worry, when we get to Form 2, when we get Form 2 where we start drawing the electron configuration of each of the elements, then you get to understand why we say all elements belonging to the same period have the same number of electron shells. But for now, don't worry yourself too much about that. Just know that there are 7 rows. So the next part of the periodic table, aside the row, is what we refer to as the groups. The groups are the vertical columns. So take note of this. The rows are the periods are the horizontal rows, and the groups are the vertical columns. And for a complete periodic table, we actually have 18 groups. 18 groups. What are these groups? Let's take a look at it once more. So the first group starts with this hydrogen. So hydrogen, lithium, sodium, all the way to francium. So that is group 1. And then if you move to the right, we have group 2, starting from beryllium and ending on radium. Then we have group 3, all the way to group 18. So that's how the elements are, the element or the table is being organized. We have the rows and then the group. The rows are the horizontals, and then the groups are what? Are the verticals. There's this interesting thing about elements that belong to the same group. According to the note we have here, elements that are in the same group have similar chemical properties, and they have the same number of valence electrons. That also, when we get to writing the electron configuration of the elements, you will get to understand that clearly. But for this level, Form 1, JHS 1, do not worry yourself. Just know that we have groups and periods. When we get to writing out the electron configuration, then you can stress yourself with that. Also, elements in the same group often form similar types of ions. That will be clarified in future lessons. But I just want to stress on one thing, that elements in the same group have similar chemical properties. Let's get back to the periodic table and see. For this particular one, all elements belonging to group 1, starting from hydrogen, lithium, but more specifically starting from lithium. Take the hydrogen out of the equation. Let's start from lithium. Lithium, sodium, potassium, rubidium, all the way to francium. Focusing on these ones, they are known as the alkali metals, and they show similarities in their physical properties. When it comes to, there's a gradual increase in certain physical properties, and physical properties run across these elements because they belong to the same group. And then the group 2 are known as alkaline earth metals. So all elements belonging to group 2 are known as alkaline earth metals. They have group 3, and then the group 8 or 18. These are known as the noble gases. So all elements belonging to group 18 or group 8, that's all those elements are known as noble gases. They are called noble gases because they are very, very unreactive. They are noble, they are innate, they are satisfied, they have fully filled electron shells. So because of that, they are okay with what they have, and they do not go into bonding with other elements. So all elements belonging to this group have that kind of property that they share with each other. And just beside these noble gases, that's the elements in the purple color, starting from fluorine, chlorine, bromine. All these elements are known as the halogens. So you can say that the group an element belongs to gives it its unique properties, and these properties are shared with other members in the same group. So that is something I want us to pay attention to. Let's move on to our next point, the major regions of the periodic table. Our periodic table that we know today has been grouped into regions. So we have blocks of the periodic table. So for the first one, I'm looking at the region that we will be referring to as the metals. That forms about 75% of the entire table. So all elements that are found in this region of the periodic table are known as metals, and they share certain properties. So let's get back to the periodic table and see what we are referring to. So look at this. In this table, I'm going to draw a line that will demarcate that region of the periodic table. So notice it, and I'm going to do it in red ink. So good, this way, good, good, excellent. So I think for this particular one, I've made a mistake. That is, I've included the hydrogen. But mind you, the hydrogen is not part of the region I'm supposed to just demarcate out. So starting from lithium, take the hydrogen out of it. Starting from lithium to francium all the way to where the red line ends on my right, to aluminium, to beryllium, back to lithium. The elements found in this block, they are metals. All the elements in this section are metals. So that's one interesting thing to pay attention to. So these are all metals. So you can see that the metals are found at the left and center side of the periodic table. That's one interesting thing. Left and center. From the left all the way to the center side, extending a little towards the right as well. So all these elements are metals. This region of elements are all metals. And what are some properties of metals? All metals conduct heat and electricity. All metals conduct heat and electricity. Simply because they have these mobile electrons moving around the metal, and these electrons are actually heat and electric conductors. So they carry this heat and electricity. And metals are also shiny and malleable and ductile. What do we mean by malleable and ductile? To put simple, a metal is described to be malleable because it will be able to be beaten into different forms and shapes. Think of it as a blacksmith having some block of metal, put it into fire and gets red hot. Then he removes it and beats it so much that it changes into different form. So the property of metal that enables it to be beaten into different shape is what we refer to as what malleability. And for the metal being ductile or ductility of metal, it simply means that the metals can be drawn into wires. So that's how come we have those copper wires. It's because of the property of what? Ductility in metals. Let's move to the next region of the periodic table, that is the non-metals. Non-metals are actually poor conductors of heat and electricity because of the absence of these mobile electrons that are able to move or carry electricity and heat. They are also brittle when solid, meaning non-metals are easily broken in their solid state. And mostly non-metals are gases at room temperature. That doesn't mean we do not have the liquid forms of what? Non-metals. We do have liquid forms, solid forms of non-metals as well, but they are mostly gases and they form negative ions or share electrons, and they are found on the right hand side of the periodic table, more specifically above the staircase. Well, we'll get to understand that soon. We've seen earlier that the left side of the periodic table contain the metals, excluding the hydrogen that I mistakenly added to it. The non-metals are found above the zigzag or at the right hand side of the periodic table, and we'll show that using black demarcations. Good. Good. So all the elements that are captured in this region are non-metals, starting from carbon all the way to helium, iodine, bromine, chlorine, fluorine. Then they are above the staircase. So you can see that in between the red region, the red demarcation and the black demarcation, we have boron, silicon, germanium, arsenic, antimony, tellurium, polonium. These elements are known as semi-metals or metalloids. They are known as what? Semi-metals or metalloids. And I think we'll be talking about that on the next slide. So all the elements in this region captured in the black are the what? Are non-metals. Are non-metals. Good. For our next region of the periodic table, we have the metalloids. So the metalloids, these are elements with mixed properties. When we say mixed properties, we are referring to properties between metals and non-metals. And we have boron, silicon, germanium, and arsenic. And these metalloids, also known as semi-metals, are used extensively in electronics. For example, we have the silicon chips. So these non-metals are very, very useful when it comes to electronics. So they are the regions between the metals and the non-metals. So the metals are captured in the red region and the non-metals are captured in the black region. And in between, we have the semi-metals: boron, silicon, germanium, arsenic, antimony, tellurium, polonium. So these are excellent examples of semi-metals or metalloids. So these are some of the few regions of the periodic table we would like to talk about. Now let's focus our attention on the first 20 elements of the periodic table. I have color codes to differentiate between them being metals, non-metals, and semi-metals. And it is interesting that for this particular first 20 elements, I've not made a mistake of coloring the hydrogen wrongly. So you can see that the metals are in that kind of orange color. Starting from lithium, we have lithium, sodium, potassium, beryllium, magnesium, aluminum, and calcium. These are the metals of the first 20 elements of the periodic table. And for your level, the only thing you have to know for now is the first 20 elements. Know their elemental names, their element names, their chemical symbol, and atomic number. Because you really need them when you get to when you are writing this electron configuration, where you'll be given only the name without the atomic number. You really need to know the atomic number to be able to write a correct electron configuration. Now, right between the metals and the non-metals, we have boron and silicon. So boron and silicon are the only semi-metals or metalloids of the first 20 elements. And the first 20 elements, we have 7 metals. 7 metals, 2 semi-metals, and the rest being non-metals. And then the extreme right of the first 20 element, that is group 8 of the first 20 elements, we have the helium, neon, argon. These are the noble gases. Then besides them, we have fluorine, chlorine, which are the halogens. But collectively, in addition to carbon and the rest, are known as what? Non-metals. So these are important points you should keep in mind for this level to prepare you for our next lessons that will be covering when we get to the Form 2 lessons. So to conclude successfully, let's pick some sample past questions on this topic to see how best we are able to handle past questions when they come around this region. For the first one, we have the chemical symbol for potassium. So the chemical symbol for potassium is, what is the chemical symbol for potassium? But before we get to the chemical symbol for potassium, I want us to get back to the first 20 elements. Of course, I want to mention something before we move on about the way the names are written. You can see that for some of the elements, Their names are actually the first two alphabets of the elements. For example, beryllium. Beryllium is B, capital B, E. And for some, the element name or the symbol, the symbol of the element, that's the chemical symbol of the element, is just the first alphabet, capital. And for some, the first two alphabets, where the first will be capital, the second will be small letter. Whilst there are some, the name of the element and then the chemical symbol are completely different. If you look at sodium, sodium is S-O-D-I-U-M, but the name is Na. Basically, sodium originally has they have names that are not the sodium. They have their own Latin names. So some of them, their chemical symbol are picked from these Latin names. So take care of that. Then we also have potassium. It has a Latin name. So the symbol, capital K, is picked from the Latin name of potassium. There are other elements out there like that as well. So take note of this. Mostly, the name of the element comes from the first or the first two alphabets of the element, or from its Latin name. Let's get back to our past question. So the chemical symbol for potassium is what? Is it Na, K, Pb, or S? Na is a chemical symbol for sodium. Pb is for lead. S is for sulfur. So our final answer is what? K, which is potassium. 2007, question 23. For the next question, the chemical symbol C is the symbol for, is it calcium or carbon? I'm sure you guessed right. 2009, question 21. That is carbon. So capital C is the chemical symbol for carbon. For calcium, the chemical symbol is Ca. An example of a semi-metal is an example of a semi-metal. 2011, question 7. Our answer is what? Silicon. So we have silicon being our semi-metal in the option that we have here. And then, which of the following is a liquid? So you can see that we have metals that are given to us out here. The only metal that is liquid at room temperature, the only liquid metal at room temperature is mercury. So it is something you should pay attention to. If you do not see the name and you see capital Hg, that is the chemical symbol for mercury, capital Hg. So mercury is the only liquid metal at room temperature. And there we have the property of a metal that makes it possible for it to be drawn into a wire is it conductivity, ductility, malleability, or resistivity? The answer is definitely ductility. So ductility is the property of metal that enables it to be drawn into wire. For malleability, like we said earlier, it means the metal can be beaten into different shape and size or whatever. That this question was actually 2006 objective question number 34. So this brings us to the end of our lesson on the periodic table. Just a brief overview of the periodic table and how the elements are organized on it. When we get to Form 2, we'll revisit this particular aspect of the periodic table and then build up on it. So this is Learner's Aid, and thank you for learning with us. So I will encourage you to subscribe to the channel so that you would not miss future lessons. See you in our next lesson.